Okay, welcome back to another video. In this video, what we're going to be looking at is kind of this function that we established in the last video of e to the x. What does this function look like when you actually graph it? Okay, so we're going to start just by establishing that, and then we'll kind of see how to transform the graph of this. Just off the top of our heads here, let's plug in some x and y values into this. So we'll plug in 0. When I do e to the 0, that's going to be 1, right? So y would just be 1 there. If I plug in 1, I would get e, right? Which is about 2.7. Keeps going, right? About 2.7 though. If I plug in 2, I'm going to get e squared, which would be like 2.7 times 2.7. So that's going to get to be a little bit bigger. Let me just do that real fast. So it's about 7.3. There's 7.4 if you round around in there. Okay. So that's your answer there. Now, so how would the graph of this actually look? Let's sketch it out. So we know at 0 we're going to be here at 1. Okay, there's at 0 we're at 1. And then at 1 we're going to be at like 2.7. So we'll do like a kind of almost to 3, right? That's at 1. And then at 2 it's going to be even bigger, right? So up at 7, 1, 2, 3, 4, 5, 6, 7. Okay. 0.4, so we need like right in there, okay? And then if you throw in negative numbers, if you remember, what do negative exponents, let me turn this a little bit so it's a little bit more straight on. There we go. Okay, when you plug in I'm having a hard time getting that to look really good. Okay, when you plug in a negative number, like -1 for instance, you get e to the -1 power, which is kind of like it's dividing by e, right? 1 over e would be what that is, and so that would be about 1/3. So it would be a small number. So what this graph is going to be like is something like that, okay? Kind of like our other exponential functions, it's just has this kind of weird base of e on it. Okay, so that's e to the x. That's your exponential graph of e to the x, okay? And so we're going to use this as kind of a parent graph for some of the transformations that we're going to do. So I'm going to do a few examples of just graphing some transformed versions of e to the x graphs. So let's look at, first, I'm going to look at a few examples here. So e to the -x, I'm going to do first. And then I'm also going to do negative e to the x. Okay. So these transform graphs that we're going to be doing, right? I did a transformation. I replaced x with negative x and e to the x, right? So I put a negative out in front of the x. So what does it do when you put a negative in front of the x in there? It is going to reflect you over which axis? Do you remember which axis it's going to flip you over? It's going to reflect you over the y-axis, okay? Because, right, you're timesing a negative with the x values, so that's flipping all the x values around, okay? So, what are we going to get here? Well, we're just going to be reflecting it over the x-axis, so it's still going to go through 0, 1, right? But instead of going up this way, right, it's actually going to be going down over here towards the axis and then shooting up over there. Okay, so that would be e to the -x. That's what that graph would look like. Okay, another one negative e to the x, what does it do when you do the negative on the outside of the function on y? That reflects you over the x-axis. So our normal graph for e to the x would look something like that, right? But then with us reflecting it over the x-axis, it's going to look like this, right? That would be our graph for that one. Okay? So let's just do a big final one to kind of get an idea of what we are doing here. So that you are ready for the homework. Let's do one like e to the x minus 1 plus 3. We'll do one more. Okay. So the minus 1 in here with right next to the x, that is going to move us how? It moves us to the right. Right? So this moves us right 1. This moves us up 3, where it's on the outside, where it's not inside with the x. Okay? So this moves me right 1, this moves me up 3. So I'm just going to take this regular e to the x graph here. We're going to move it right 1 and up 3. So normally with my e to the x graph, I go through 0, 1, right? But now I'm going to go right 1 and then up 3. So 1, 2, 3. Beyond that, up to 4. So that's where that new point is going to be. Okay. So normally it goes through 0, 1. So just move that over 1 and then up 1, 2, 3. Okay. And then the shape is going to be the same because you're not flipping it over any axes or anything, but essentially it's going to be coming down. The axis will be up 3, right? So it's going to be kind of like going like that, and then it's going to be shooting up afterwards. Sorry, this graph doesn't look the best. But it's just shifted up 3 and then 1 to the right. Okay, that would be your graph there. Notice these do have a horizontal asymptote, like most exponential functions do. Like this one, we've got a horizontal asymptote here on the x-axis. These ones too also have horizontal asymptotes on the x-axis. This one has a horizontal asymptote up at 3, right? Because it got moved up 3, and that's where it would be. Okay. So that kind of gives you an idea of how you graph e to the x. It's basically the same as our regular logarithm functions, or not logarithm, exponential functions, just with this particular number e. Okay, I will see you in the next video, and we are going to look at compounding interest, which is actually the use of e to the x.